One of the first ways children learn to describe their world is through the use of colors. We know that the sky behind these geese appears blue, and that this jacket appears red, and that this sunset appears orange. But where do colors come from? How do our eyes receive and process color? And what role does light play in enabling us to see color? During the next few minutes, we're going to explore these questions about color, while also taking a look at some of the properties of light and the way it interacts with matter. The rays of the sun bouncing off the surface of this lake are blinding, as is the light from this mirror. You decide. What's the term used to describe the process of light bouncing off objects? That's right, reflection. This is the process of light bouncing off objects. This ice is reflecting the bright rays of the sun. Shiny surfaces such as ice and water can reflect a large amount of the light that strikes them. Light is not only reflected, but can also be transmitted or absorbed. Glass is a breakable material that allows light, but not objects, to pass through it. A substance such as clear water allows most light to pass through, allowing us to see this purple starfish. The water is said to be transparent. You decide. What's the difference between this plastic wrap and this wax paper? This plastic wrap is transparent, allowing most of the light to pass through it, which enables us to clearly see the fruit in the bowl. The wax paper is not transparent, but instead is translucent. Translucent materials only allow some light to pass through them. Translucent materials scatter light. Many plastics are translucent, as are these curtains, allowing some light to pass through. The objects behind them cannot clearly be seen. In the case of this duck, it's neither transparent nor translucent. It's opaque. It is not possible to see through opaque objects. Opaque objects tend to absorb some light and reflect some light. This helps explain how we see the color in objects. Let's take a closer look at color. The mountains seen here in early summer are a sea of green. What causes this green color? Millions of green leaves give these hills their green color. The sun produces light in a variety of colors, including red, orange, yellow, green, blue, indigo, and violet. Green leaves absorb many of the colors coming from the sun. Plants use these wavelengths of color along with other electromagnetic energy to make food via the process of photosynthesis. But leaves do not absorb green light. Instead, green is reflected back and is the color we usually see the most when looking at a plant. The brilliant color of this bright red car behaves similarly. The car absorbs all of the colors of the spectrum except red, which it reflects. On the other hand, this black car does not reflect any of the colors. Instead, black absorbs all colors. Black is produced when the colors of the spectrum are absorbed. You may have noticed that black objects, such as this road, tend to get warm during sunny weather. That's partly due to the fact that black absorbs all of the colors of the light spectrum. The opposite holds true of white. White reflects all of the colors in the spectrum, and that's why it's a good idea to wear white in warm weather to help keep the body cooler. Goggles are helping this skier see the terrain as she speeds down the slope. This fisherman is wearing sunglasses. Without them, the glare off the water's surface would be too intense to see the fish. These sunglasses are specially designed to filter light. They're called polarizing sunglasses. Polarizing filters, including sunglasses, have many tiny parallel slits that have the ability to reduce vibrating light that contributes to glare. They kind of act like Venetian blinds, with many parallel slits allowing planes of light to pass through. The light that passes through polarizing filters is called polarized light. Notice how the polarized light that has passed through the filter is vibrating along a single plane. This helps reduce glare. As we already mentioned, light can be absorbed or reflected. Look at the shape of this pencil as it passes down into the glass of water. You decide what property of light causes this pencil to look as if it's bending. The answer is refraction. The property of light that makes objects look differently in water is called refraction. Refraction occurs when light passes from one medium to another. As light passes from air into water, it slows down, causing it to bend when it strikes the surface at an angle. The bending of light causes the pencil to appear as if it's bent. Refraction also causes objects underwater to look bigger than they actually are. Diffraction is another property of light. Diffraction is the bending of light waves around the edge of an object. The process of diffraction is similar to the water in this stream bending around this rock. Diffraction is part of the reason you see the lights of an oncoming car before you actually see the car. Diffraction is also part of the reason the morning sky appears lit before the sun actually rises over the horizon. This smooth lake surface shows a near-perfect image of the bird flying over it. And the rearview mirror in this car helps the driver to see what's behind her. These objects are reflecting light. As we already mentioned, reflection occurs when a wave hits an object and then bounces off it. Light behaves like a ball bouncing on a flat surface. When a ball hits a surface head-on at a right angle, it bounces back in a straight line. But if it hits at an angle, it bounces away at an equal angle. Light behaves in a similar way. For example, when light from this laser light hits this mirror at an angle, it bounces or reflects away at an equal angle. The light rays approaching a surface are called incident rays, and the light rays bouncing off a surface are called reflected rays. The angle at which light strikes an object is called the angle of incidence, and the angle at which light bounces off an object is called the angle of reflection. The law of reflection states that the angle of incidence and the angle of reflection are equal to each other. Light, however, does not always reflect regularly, as we've just seen. Regular reflection only occurs on very smooth surfaces, such as mirrors. In most cases, a type of reflection called diffuse reflection occurs. Most objects have an irregular surface. This brick wall, for example, when viewed closely, has many bumps and pits. When light strikes surfaces like these, it's scattered irregularly. The atmosphere scatters light from the sun diffusely. This is because the atmosphere is filled with gases and dust particles that scatter light, allowing us to see objects that are not directly hit by the sun's rays. There are a wide variety of mirrors. Mirrors are categorized based on the shape of their surface. They include plane mirrors, concave mirrors, and convex mirrors. Let's first take a look at mirrors that you're probably most familiar with, plane mirrors. A plane mirror has a perfectly flat surface. The reflection of objects in a plane mirror appear their actual size and are right side up. However, the image is reversed. Let's take an example. If you raise your right hand while looking into a mirror, it appears that the left hand of your reflection is raised. Also, when you place words in front of a mirror, they're reversed. You decide. Why is the word ambulance written backwards on the front of this ambulance? It's written backwards so drivers can see the word correctly when they look in their rearview mirror and can then make room for the ambulance to pass. Have you ever seen your reflection in a spoon? A spoon is a type of concave mirror. A concave mirror is a type of mirror in which the surface curves inward. Concave mirrors are very useful in telescopes, helping to gather light from objects in space. Light rays coming in parallel to a concave mirror are reflected toward and through the same point called a focal point. In turn, light reflected by a concave mirror from a light source positioned at its focal point reflects light rays parallel to one another. Concave mirrors are useful in car headlights, helping to form a powerful light beam. The same holds true in flashlights. Behind the bulb is a concave mirror. The concave mirror helps to form a strong, focused beam of light. Back to our spoon. If we flip the spoon over, it now forms a convex mirror. A convex mirror curves outward. In convex mirrors, the image appears smaller than the actual object. Quite often, the side mirrors on cars and motorcycles are convex mirrors. They're useful because they provide a wide field of view. You may even have seen convex mirrors in stores, so that store employees can see down aisles. This thin piece of glass is a lens. Lenses are used in a variety of objects, such as eyeglasses. Other lenses, such as these, are used in cameras. A lens is a transparent material that bends light. Most lenses, such as this camera lens, are made of glass or plastic. There are two main kinds of lenses: concave lenses and convex lenses. Concave lenses are thinner in the middle and thicker at the edges. Convex lenses are thicker at the center than at the edges. This magnifying glass uses a convex lens and makes objects appear larger than they actually are. During the past few minutes, we've explored many of the different properties of light. We've seen how objects reflect light and absorb light, as well as how light can be refracted or diffracted. We also took a look at the characteristics of concave mirrors and convex mirrors, as well as concave and convex lenses. So the next time you notice the color of an object or use a mirror, think about the properties of light. You just might think about light a little differently. Fill in the correct word when you hear this tone. Good luck, and let's get started. Number 1 is the process of light bouncing off objects. Number 2, objects allow light to easily pass through them. Number 3, objects absorb most light. Number 4, reflects all the colors of the spectrum. Number 5, filters reduce glare. Number 6, the process that causes the pencil to look as if it is bending is Number 7, light rays approaching an object are called rays. Number 8, a reflection occurs off an irregular surface. Number 9, this is an image of a mirror. Number 10, convex mirrors provide a field of view.